Hello, guys. Not sure if anyone has joined yet, but hi. So today we're going to continue where we left off. Yet, I just want to kickstart it by saying that we have a website. It's called whitehathacking.tech. You can see it down in the description, whether you're Twitch. If you just scroll down, we have courses for you. We're doing a programming fundamentals course right now. It's ongoing, and we're doing live. You can follow it completely free. We also have a Discord community. You can just click on it and join it. Very active community with people from all skill levels. You can things, learn with anything. We also have our own merch page, which has really cool merch. If you want to support this channel or content, we're coming up with new designs as well at some point. And yeah, that's basically it. So where were we last stream? So in last stream we were doing a server in our client for our ransomware, and there was a problem that I just couldn't solve. The server here, the payment checker server, was not everything seemed fine, but from this other from the client, we couldn't connect to it. There was a problem, and I spent like 30 minutes or so on stream trying to figure it out, and I couldn't. And it's funny, as soon as I clicked end stream, I just scrolled through the code and instantly spotted it because it was incredibly obvious. Huge facepalm moment. So it turns out, if you look at this script, so what is it doing, right? So we set up the payment thread, we daemonize it, we start it up, accept the connection, perform the auth exchange, then we close the socket, and then nothing. So the program exits, of course, right? And the thread is a daemon, so it will close with afterwards. It will close as the main thread closes. So really what you want to do is you want to do a while true loop here, which is I always do this, but I forgot that I didn't do this before. I forgot to do it, and so we just want an infinite loop so that the main program does not end. So we have the thread still running. Alternatively, you can not put it as a daemon, and the thread will not exit when the main thread exits, but then you still need to kill this somehow at some point. So I prefer to do it as a daemon and just have this while true loop and sleeping. So if we try this out, so the only thing that we did here was we created our listening server on the payment checker, and we just are printing whatever we receive. And here the only thing we do is we connect and we send hi. So now if we run this, let's run quick. There we go. PowerShell, set two windows here because, well, oh, they're opening in this other screen. Oh, so if we now let's activate our ransom environment. Oops. Go. Now if we run our server, oh, it's the wrong directory, my bad. If we run our server and our client, we should now see, the normal screen here, blah blah, but we also see the hi here that was sent. So everything seems fine. Now what we're gonna do, we can Control-C out of this. So now let's actually make the monitor a payment. So as we were doing before, so forget this. So we have our message size because that's the header. And I think this is actually exactly what we want to do. So we receive a response. If it's false, it's not paid yet. So we might just print this. Else, we have to do an actual check. I'll put this here so we don't forget that we have this. But else, we do everything else. So we might want to sleep. So as we connect, we might want to sleep for like maybe not 15, maybe 10 or so seconds to simulate the payment. And we have to send something, right? So in our payment checker, yeah, we have to send something, of course. So it's going to be the exact same thing, right? This is going to be it, and our BTC is going to be equal to whatever we receive. So I'm just going to copy this because it's exactly the same. Now, what we're going to do is we're going to perform our check. So we don't actually need to do a check here because this is all we want. We want to send it. So first we need to send, of course. So let's send it. Let's do a send message of our address into this socket. And after we sent it, we need to receive it. So we need to receive a response, and the response can be false or true, or something else. And if it's false, it hasn't been paid, and do bytes here. Also, if it's not false, we're going to actually, this should only return things that are easily decodable. So I'm going to do a decode here. And if it's not false, then it does this, and it decrypts with the key. And where is this key coming from? This key is given here, so we're not going to give a key anymore. So in our client, we're not going to give a key here anymore. Instead, the key is going to be this. So I'm going to say key equals this, and if key equals false, then hasn't paid. Otherwise, this happens. And there's a sleep to simulate that it's decrypting a lot of files when it's just decrypting, one in this case, or just a couple when we go into our test box. Great. Now on the server is where we do the actual check. So let's make a do actual check. And now, oops, not receive, bad. So we're just gonna have a check equals true, and this is where the check would happen. And if check, so if the Bitcoin address is checks out for user in keychain, if keychain, you know what? Let's actually change something else as well. I just realized something that would be a problem. In our keychain, when we do the auth exchange, we calculate a user ID. We don't actually need this for anything. I was thinking the user ID should just be the Bitcoin address, right? So instead of this, what I'm going to do is I'm going to say Bitcoin address equals this. Well, exactly what we had here. And now, if Bitcoin address not in keychain, we're going to add it. And the Bitcoin address would be this. And the address is just going to be equal to the key. There's just nothing else going on. We don't need this anymore. And so now, send message this, sure. Okay, great. So now what we're doing is we're storing only the Bitcoin address and the key corresponding to. So here, as we check for payment for that particular address, all we got to do is say if, or actually I can just say if check, I guess. If check we need to send it back, so we can have our keychain.get ACR code and default to false. And we do a connection.send, well, default to yeah, and now we have a send message key. We don't have any other key, right? Send message key and to the socket connection. And of course, and this is actually all we need to do, and else send message false to this connection. So now we can check out what is really happening. If we have any errors, we might have some. What happens? Well, it's got our server, it's got our client. Oh, oops. E. Oh, because here we don't want the key being sent there. This up. I want to see if everything is received. Display hacked. Oh, display hacked itself has the key as well, of course. Where's don't need this key anymore. There we go. That was the original message anyway. So now this shows up. We wait like 10 seconds for stuff to happen. So this is what our keychain looks like. This would be the address. This would be the key decoded. Oops. Bytes object not to be encode. Send message. Where? So let's go into 24. Huh. Wait. Oh, is the key already in bytes? Is it? It shouldn't be. Decode. Oh, okay. So wait, we need to go back into our auth exchange. So this address equals this. The key is going to be the encoding this, and this is going to be equal to the key.decode. So we send message with this. Yes, great. And then we send the key. Yes. So where is this coming from? Let's check it out. 24. Check it out. Oh, splash, sorry. Oh, of course. So we're sending the address here. This address that we're receiving is from here, which is the receive without decoding. So we should decode this. Let's check it out again. Go. Works. There we go. But now something else didn't work out. So int and string. Oh, okay, because we're decrypting. Yeah, okay. Yes, and this is the other part of it, right? So now actually it is working, and we can see that it is working because it got into this part, into the scripting part. But now we have to also handle, of course, what we're getting, because this key that we're getting is going to be, so if we print it out, let's print it out so we can see exactly what's happening. So the client is, well, we have to rerun the server, of course, because only accepting one connection, closing right after. So I should put the timeout a bit less so we can see this better. But the key that we're getting, of course, is going to match, see, it's going to match this exactly. So we have to base 64 decode this first. So we have base 64. So all we got to do is set this equals base 64, that base 64 code, and we're going to decode this whole thing. And now we're going to still print key so you can see exactly what is happening. But so we have a server, our client. This shows up. we're gonna make this as we did before. So full screen, all good. There we go. Now we got our key, which is bytes, and now this exited. Everything was, worked. So now, assuming that this works, let's actually test this out. So what we're gonna do is we're going to, we don't need to print the key anymore. And now we need to convert our client. Our server doesn't matter. We need to convert our client into. So as we touched on before, we can do, let's make a new directory called build, just so that we can just delete everything that's inside of it later on. We cd to build, and we do a pi installer -f for one file -w for windowed mode, client.py, // because it's on the directory. And now it's going to, we're going to automate this process. Worry, but making the pi installer file. Great. There we go. So we built the executable, which is right here. So now we're going to go into our virtual machine. So let's start up our virtual machine. That. Oh. Starting up. Is it possible for the victim to turn off the ransomware? Well, not as a common user, because the way that we've seen it here, right? So let's just do this again so that we can just again first. And so when you explore ransomware here, open it up. So what happens when you it's on the other screen, sorry. So, and we're gonna see this in the other screen as well. But so what happens when you execute the client is this shows up, right? And this would be the only window that you see. Now at this point, we can just minimize it or just close it. But the problem is, as soon as you close that, it doesn't really help you, because that only appears after everything is encrypted. If you look in the client, it first encrypts everything and then it displays the screen. But I also forgot this. I'm sorry. So this I commented out before. We want to uncomment it, because this is what is going to make it full screen, always on the screen, and you cannot exit from it. So, but while this is encrypted, you could theoretically just kill the process if you know that it's running. But we're gonna also cover some ways to make it not easily terminated. We can have multiple threads checking on each other to see if any of the threads is terminated, and only one of them is actually encrypting stuff. So if it's terminated, another one spawns up immediately. We can do some privilege escalation to create a service that users cannot terminate. There are a lot of things we can do, and we will explore that later on. For now, I'm just concerned about the actual functionality of it. So we have our attacker. Let's delete this. And we have our test. This test is a folder called test that has a lot of stupid stuff. So it has a secret folder that has blah and secret written on it, passwords with a bunch of text, cron folder with some cron accounts. It's just text data, and then here we have an executable that actually works, by the way, just so you can see that it works. And this is just to prove that the encryption can encrypt and decrypt executables as well, because that's pure binary data. We're going to FUD or obfuscate file. There's not a lot of need for obfuscation when you're doing it in Python. It's kind of one of the cheap ways to evade antivirus software, because I'll show you. I'll upload this to VirusTotal at some point, and you'll see that there really is no. It's not really detected, except for the some PyInstaller artifacts that are not actually that don't actually have anything to do with the virus itself, but I'll tell you how to get around that in a minute. Let's just execute this so you can see how this will work. Oh, I need to build it again by the we had to uncomment some stuff, so I have to build this again. So let's go on here. Where is it? Where are we? Here. Oh, build. Do that. And I'll show you that it's not really detected by anything, or shouldn't be anyway. Yes, yes, we're waiting for you. There we go. So right here, what the hell? Are we running something that I don't know? This virtual machine is a bit messed up already. Meanwhile, I can show you that. So at this point, I believe it would actually be detected, but not because of our script specifically, but because of PyInstaller. Oh, it's here, books, ransomware, build, distribution, client.txt. So we're uploading this up. And we'll wait a while for this detection to come up. Okay. Okay, nothing really is happening on here. So we do have some detections there, but we'll get around that, don't worry. Oh, come on, it can't be this freaking slow. Okay. So, oh, I need to kind of check our network. We're on an internal network, which would work, but I don't want to spawn up another virtual machine because I think it would lag a lot with the stream. So we'll do something like this, and we'll do. You should definitely have more viewers. You totally deserve it. Most of the other streamers don't explain the whole process like, oh, thanks, I really appreciate that. Yeah, that's the whole point of this. So yeah, we have two detections. Yeah, Signet and SecureAge Apex. And they don't detect what kind of malware it is, just that it has a high malicious score. And this is because it's detecting PyInstaller artifacts, which is the program we use to convert Python script to executable. But we can get around that by making our own. So let's see if we can open up, if this virtual machine will not die on me, if we can open up, yes, come on. Come on. Here we have our build folder. Oh God. Come on. Oh, we need to tweak our settings too. Wait, let me check. Oh no. It's gonna take a long time. I forgot to tweak the settings too, because obviously we're not doing this local anymore. So, well, we're still doing it local, but not on the same machine. So we have to go here back. I'm sorry. I just woke up. Into our client, of course, and we have to connect it into here. There we go. I don't care that you see that's my internal IP address. And wow, this doesn't even load the page. So let's delete everything in here and rebuild the whole thing with the same one command. There we go. But even though this still gets some detections, it won't most of the time when you're dealing with when you're dealing with that was not part of the traffic light, was it? Needed. When you're dealing with other people, they won't really get detected because nothing else really detects it. You know, like people usually would have another antivirus. It would not get detected anyway, but we will get that number to 0. Don't worry. Let's refresh this since it should be built. Distribution, here's our client. Let's just copy it to our directory. Oh God, seriously? See? Oh, did I not copy it? This is our, oh, I did. This is the client. Let's just delete this. We don't need this. Oh, it's not even here anymore. Never mind. Okay, good. So we'll refresh. So this will encrypt our test folder because that's what we made it do. So as you can see, executable is executable. Our passwords are open. So now let's execute the client. First, we have to execute the server, of course. So let's execute the server. And let's see if this works. So we're running it. Oh, it didn't actually receive anything. Oh. My bad. This is actually my bad because it appears that I have provided it the wrong IP. Yes, I did. I provided a different, the IP for a different interface. So let's kill this for now. Oh God. Okay. What is my current IP for the interface that I actually using is this. So let's, there we go. That is the IP address that should be, yeah, it failed to execute because it couldn't connect. Because there's nothing listening on the port that I was in. So this didn't receive a connection. So let's rebuild the script. Sorry for all of these little details that sometimes get missed. There we go. Okay, let's, oh, I should have deleted that. Oh, build. Did we delete everything on build? Let's check if we did. I love deleting everything there because a lot of the times, especially with especially with PyInstaller, if you leave some stuff, it might actually cause some problems. So let's rebuild that. It should be easy now. We already have our server listening, so as soon as this is done, we can run it. There we go, and refresh. This should be, there we go. So distribution, client, let's copy this. I'm copying it with the right click and left click to make sure that, like, you know, okay. So now let's run it, and come on. Okay. Okay, let's check out if we can. I provided the correct IP, did I not? 164. Let's try to ping it just to see if we can see it. We can see it. Is this not the IP that we're providing? Client here, 8080. Oh, sure. Our splash is also connecting to a socket. Needs to be there. And you know what? I'm also going to do this just in case I might have. Also, I only tweaked that one. I didn't tweak this one, but that doesn't matter. So now everything should be fine. They should see everything. Okay, let's try that again. Yeah, a lot of waiting on this. What splash? Oh, okay. I think you didn't restart the server. Oh, maybe I did not. I'm sorry. I am a bit tired at the moment, but I'm trying to concentrate here. So let's start the server up. The splash, by the way, is what will display the splash screen. The screen saying, "Oh, you have been hacked. You need to pay this amount for unblocking whatsoever." And it's also what's going to, here in our monitor payment, it's also going to query our server to check if we have paid or not. And if we have paid, it turns green and it says it's being decrypted. That's what the splash is for. It's for messaging the user and checking for if it's decrypted or not, if it's paid or not. Our server is, of course, for storing all of the keys and for giving out the keys that the clients will use to encrypt. And the client is used to encrypt and show the splash. So let's refresh this. Let's run the server. Oh, there's no server in this directory. Of course, there is not. Let's run the server. It's listening. Now let's get the client there. And let's hope that I didn't do. How does it check if the payment was made? Okay, so right now it doesn't actually do a real check, but what we will be doing is the splash thread on the client will send a query to our server to a different port just with the Bitcoin address. And then the server will go on a Bitcoin exchange website API. Like, it's really easy. There are APIs for all of that where we just check the balance, the current balance of our wallet. And if we generate a new wallet, which is easy as well, we can generate a new wallet for each client. The client comes and asks for a Bitcoin wallet, and you generate a new one on the spot. If you generate a new one, you only need to check the balance if it matches exactly what they're supposed to pay. So that's how it would check the payment. Oh, come on, just go there. Okay, so let's try this out. So the server is listening. Our client is gonna connect, so hopefully. Still not connecting. Is it a firewall issue on my end here? Could be, actually. Oh no, it did connect, never mind. So yeah, this is what happens, by the way. Now you cannot Alt F4. If you try to Alt F4, this won't work. If you try to do task kill, okay, it exited too fast. But yeah, everything is back to normal, and I wanted to show you something. I wanted to show you it working as well. So I will remove this again. This is what makes it full screen, always on the top of the screen, and impossible to exit from. So if you try to exit or task kill Python or anything you want to do, it will come up and say, hey, you can't do that. But I'll disable that so that you can see that the files are actually encrypted. And let's also make a larger delay. So let's make it like a 20-second delay here. Maybe like 5-second delay here. I can show you again, by the way, the task still not really working. So if we exit the server, if you execute the server again and you click here, by the way, wait a second, refresh. Okay, all the files are encrypted now. Let's do a task kill f python.exe. Sorry. Oh, wait, that worked? Damn. Yeah, we will fix that. I think it's because I'm pretty sure I know why it's happening. But we can definitely fix that. But yeah, if you try to Alt F4 or kill it from the task manager, it won't work. You have to make a different build for each client. Oh no, exactly. So that is the best thing. So you only need one client. But in the start, the client will send a message to the server saying, hey, I'm in a computer. Give me a Bitcoin address. And the server will give you a Bitcoin address. And then the client will have a new Bitcoin address. So basically, the server is the one that creates new addresses. And you only need one client, because if you have 1,000 people with the same client, they will query an address and the server will give them a different address. So yeah, we generate a different address basically through an API. Exactly. But yeah, I wanted to do a build where we don't have the exiting protection, so that you can see that we actually encrypt everything. So let's do that real quick. So cd builds, and let's build it again. Oh, so thank you so much for following. 3 with a bunch of 3. Thank you so much for following. Really appreciate it. And by the way, we do have a Discord community. If you scroll down to the description, it should be there. We also have a website where we're making this whole course in text version as well with exercises. So you can definitely check that out too. It's whitehathacking.tech. Okay, so we have the build here. Let's name this client client old. Type of that, doesn't matter. Drag this up here, make our server. There we go. Now, if we execute this client, the window that will appear will not be, it will be minimizable and exited. But now, if you go into test, you can see everything is encrypted. This is about the firewall, it doesn't really matter. So if you go into executables, for example, you can't, you can't execute this. If you try to open this up, it doesn't start with MZ. It's not even like an executable anymore. It's just complete encryption. Now it's being decrypted, and now it works again. Right? That's the whole point. So we have the functionality down. So now what we can do is to splash, we can just uncomment this again so that everything is commented out. Everything is working as intended. And that's it. And that's our server and our client kind of complete. There is one issue with this, of course. The whole build that we did was for a server and only one client. So if you look at the server, it starts the payment thread, doesn't matter, and then it goes for the auth exchange, which just after accepting the connection, and then closes the connection, and that's it. And it only connects with one client. But what if we have 3 clients at the same time, or 10 clients at the same time? We want to be able to also handle that. So here's where we can do a bit of threading. So how would we do this? Well, when we accept this connection, right? This is of course blocking. So what we can do is we can start a new thread with this connection. So let's actually do that. We kind of do this already, but we have a function that takes care of this. But instead of this function being executed here, this function will be started as a thread. So what we'll do here is, well, we have our while true. And in here, we can have this. And then we have our, we create a new thread for this, with the target being the auth exchange, of course, and the arguments being the same. So the connection, the address, the keychain. We can make this a daemon too, so that when the main thread exits, this will exit as well. And we start it. Easy. Over and over and over again. And that's the whole point. So now you can have 2, 3, 4 clients connecting at the same time. We have to listen, if you want 10 connections and accepted before it refuses new ones, you can do that too, but we don't actually need it. It will just spawn a new thread for each connection that is being received. And the payment thread, the payment check, currently only listens for 1 as well, and we can change this too. So right here, we don't need to print this. The payment s.accept, yes. And here what we can do is do our while true. And now all of this can be done by our payment thread, which is going to accept the connection and I guess address maybe. I don't know if this is needed yet. And we can start this up. Payment thread. The naming is not very good. Whatever. Payment thread equals. And there is a better way to do this, and I will show you the best way to do this. And when we start learning about object-oriented programming in Python, which we will do probably in the next lesson, I believe. And we can organize all of this very neatly, very easily. But for now, this also works because it's always important to show some logic behind some things, even if they're not the most optimal way. I gotta leave. Thanks for sharing your knowledge. I'll be back on another live stream for sure. Thank you, Skywalking, for showing up. Stay safe, man. Really appreciate it. So the arguments here will be, of course, what we ask there. So the connection, the address. Actually, the address isn't used at all, so we don't need the connection at all. Remember to put the little comma here because otherwise it won't interpret this as a tuple. And right now it's not really clean. We're just starting new threads and we're not checking if we're actually going out of bounds or anything. It's pretty dirty, but it would work. Yeah, we get this and message connections. Great. And in our splash, we should also do a while true because we're trying to monitor for the payment, right? So we want to do a while, we want to do a while true loop here to send the message and get this. And do a time.sleep, say 5 between each. Else we're going to break and we're going to execute this. So right now what's happening is as soon as it connects, it goes for an infinite loop, sending the message trying to get the key back. And if it's always false, it's just going to print not paid yet. And otherwise it's going to break and it's going to, of course, complete our decryption. Great. So I think we're good here. So now, theoretically, and this is the cool thing about this. Let's run our server again. Oh, something is wrong. A 1 was given to payment checker where? Payment thread. Oh, we don't need the keychain. Okay. Let's go. It's again. Now, of course, we have to rebuild this, but we're used to having to rebuild all of it. Just that. And activate ransom. Servlet PY. It's just waiting for stuff now. Now, let's first do a little sanity check, just making sure. Oh, it's powered off. Oops. Let's make sure that this works. By the way, how many? 2,000? How many do I have now? How much can I still? Oh, okay. Let's open both of these actually. And I also want to make sure that our network is bridged. Let's make it a bit smaller. This one got a bit try and restart that one afterwards. Come on, you want to open? Yeah, you do. There we go, open. Let's try the other one as well. Oh wow. Yeah, I was testing a few things here. So this one is exactly the same machine. Let's go into build. Oh, we didn't build it yet, did we? Oh, we didn't build it yet. Oh God, idiot, we didn't build it yet. Also on the server, I want to do a try except here. Oh, actually, I don't want to do this. What I want to do is our executable thread. No, our what shall I call this? Our main thread. Doesn't really matter what we call it right now. Let's also create a main function here. Which is going to take an S, and it's oh, we don't need to take an S at all. We don't need to take anything because everything is there. Rate thread.daemon equals group start. And the reason I'm doing this is because now I can do try this except keyboard interrupt print closing. Okay, and now what we can actually do is we can the idea is so that we can always control C out of it and end everything at the same time without having to do all of these so now if I go to server, if I want to end this, I just control C and it says closing, and it should oh, oops. Idiot. I didn't break from it, my bad. Let's try this again. Idiot. Okay, let's go. Yeah, now I can just control C and it closes everything without having anything being blocked and stuff. So let's execute the server. Oh, actually, I need to build it first, right? That's important. Let's also go to the other one and try to start it out. Hopefully I'm not, there are no problems with me streaming while having two virtual machines on at the same time. Let's execute the server. Now for a little sanity check, I'm going to open the client here to see if it's working normally as it should. Taking some time. Something seems to be wrong. What's wrong? Is it not running? Did I make some mistakes with our threads? Is it just being slow? What's wrong with this? We got no errors. Always a good thing. Except when it's not working. Oh, oops, I exited. Yeah, something seems to be wrong there. This one is doing updates. Check our network settings. Yeah. Programming Basic 7.2 ransomware. Thank you so much for following. I'm not god at Twitch. There we go. Sorry. Oh, there we go. It did work. It was just slow as fuck because I'm running two virtual machines. Okay. While streaming. So this works. By the way, I cannot Alt F4 or close it in any way. That's the idea. So that didn't work. Also, we can actually go away. Yeah, now it finished. And we have access to our files again. Great. So it is working. It's just slow as fuck because I'm running two virtual machines. So now the reason why I opened two virtual machines is to show you that now, because we're threading everything, we're creating new threads for each connection. We can have two connecting at the same time, two clients receiving, potentially, if we make the function for it, receiving different Bitcoin addresses and having a separate keychain. So let's go again. This is our test folder. Let's open up our ransomware build. Build here, distribution, and let's just copy here. Now let's execute the client here. And we can execute the client here again. And we can take a look at this, our server that is going to print out the keychain at some point while we take a look at these two machines. Because this is going to take a while, apparently. In any computer, in any modern computer, this would be instant because we're just encrypting like four text files. Would be completely instant. Let's go, but nope. Okay. I wonder if you can get banned from Twitch because of that. I don't think so. It's just an instructive project. We're not trying to use this to grab other people's money, to steal money from people. We'll just use this as an instructive project because a ransomware has a lot of things into it. It has a tiny bit of GUI coding, which is nice. It has some networking as well, which is great. We have a server and a client and we need to communicate, so that's a skill as well. We have the actual encryption, so we have to deal with opening files, changing files, dealing with bytes. So I think it's a really cool project to work with. You know, with the whole Twitch situation right now, I don't really know what the Twitch situation right now is, to be honest. I'm a bit out of it, unfortunately. If you could explain it to me, that would be awesome. I don't really know what's going on. I'm kind of new to the whole Twitch scenario. Really good training though. Gotta agree. Yeah. Thanks for agreeing with me. Oh, come on, dude. You can run it. Is it even running? Is it even? I think it's running, but let's run it again just in case. Come on. We don't need this open because we don't see it anyway. Oh wait. Oh wait. It's not going to work. Oh, I'm an idiot. It's not going to work. Because the reason why it's not going to work is because I'm giving the same Bitcoin address to both of them, and it's checking if it's already in our keychain, which of course it is because it's the same. So let's just randomize it. So let's import random here, and when we do our auth exchange, instead of a random Bitcoin address here, let's do a, I don't know, join, and then make a little iterable random.randint, I guess, from 0 to 9, well, sure. For variable in range, let's say 10. Okay, let's do this. This should work. Now it's going to be a random, and now we're also going to see a random address do, which is an idea. So let's try it again. Is it running? Yes, it is. Let's try this. Let's try this. Let's put this up here so we can see printing stuff. Oh. Oh. Oh, damn. Yeah. Okay. My bad. Just make this a string, I guess. Let's restart this. Let's make this a string so that we can actually run it. There we go. Let's run it both again. It's just a whole mess right now. Oh, there we go. So we have one, which is a generated object because because it is a generated object. Of course, I'm an idiot. And the other one is not receiving yet, is it? Is it? Did the other one work? I don't know. Didn't see it working. But yeah, but this one worked, and now the test is unencrypted again. This is really bad if you have like really, because I'm having like really slow VMs right now. Oh, there's a better way to do this, by the way. Let's just do you know what? I'm gonna do a little alphabet, which something like this, and we're just going to do random choice alphabet 10, and we're gonna join this, I guess. Let's do this. This should be a bit better. This failed, of course, that's not a big deal. Okay, so now let's try this again. Oh, I didn't run our server, did I? Here. So now you have like a random thing. Oh, did I not separate that? I didn't. Ah, fuck it. Doesn't matter. So it works for this one. It's not actually working in parallel for some reason. We've got to figure that out. Because it works for this one, but it's not working for this one. Why is that? Why? I wonder. Let me. They're just abusing their power. Oh, okay. So mods are literally doing what they want right now. They can ban anyone. Oh, really? Creating female stream is a lot better than male. Damn. I didn't know that at all. Damn. Oh. What did I want to do? Oh, this is the auth exchange. Oh, yeah. No, but there's a different auth exchange for each. Right? Main. Where's the main function? So we accept it. We do this, of course. Great. We start it up. Oh, yes. Yes. There's no while true in here. That's why. There's no while true in here. Great. That is why. Okay, we figured this out. So now let's close this, execute it again, and there are these errors if it can't connect. We'll get rid of these at some point. Now, if we click twice, we should have just two different numbers. There we go. So we have like a random address here. We should also have a random address there. I hope. Come on. Did I do something wrong? So the main thread started. Um, and the main thread just cycles through connection, then starts the auth thread. Yeah, this should work for both of them. Yeah, there we go. So it did work for both of them, but one of them started first, the other one started a bit later. But the point is, it does work. And just, I guess, to kind of prove that this works multiple things at the same time, let's actually do it local. Because we have a test server, we might as well use it. Well, female streamers, I understand why people would be a bit, why people would, I guess, give some preferential treatment to female streamers. I understand why, because they're not a lot. Well, at least before, because there didn't used to be a lot of female streamers, and they want to get more female streamers into it. And I'm guessing that female streamers also bring a lot of revenue. I'm just guessing stuff here. I'm not actually sure, but I'm guessing that they do. You know what? Let's exit these machines because obviously this is going fast enough for what I want. But like if they're actually doing that, it is a bit wrong in my opinion, obviously. But it's at least a little bit understandable from where they come from a bit. But yeah, it's not okay. I can't even say on stream anymore. Honestly, like, yeah, you can say a lot of bad stuff, but you can't say something like that. I don't know, like, is there a reason why you can't say that? As in, is there, was there something that happened with people using that word that made it really bad? There we go. By the way, to prove it, we have like two screens at the same time with different numbers. We received both at the same time. It's just the virtual machine was super slow and we couldn't get it to actually be on sync. In sync. Yeah, people call them mod because it treated female streamers a lot better. Well, yeah, that is a complicated situation going on here. Well, there. Oh, here. But I don't know. I don't like to get into a lot of those drama things. I love drama. Don't get me wrong. I do. I really love drama. But I don't like being involved in it. But I love talking about it, of course. Um, they banned a lot of big streamers, male ones. Salinity isn't her cat on. Wait, what? Really? What? And she had to ask the mods to ban her? What? That is crazy. That is absolutely insane. Holy crap! That should be illegal technically. I mean, wow. Oh, I have to like look up some of this Twitch drama. And she gave the cat vodka. Oh damn, okay. Which is no bueno for cats. Yeah, I get. Yeah, of course. Holy crap. That is wow. I mean, I guess that generated a lot of viewers. But I mean, there's a line, right? You're gonna get banned if you do something like that, or you should at least. But honestly, like about calling mods a particular name or whatever, I guess that they can just ban, like it is in their terms of regulations, they can just ban whatever, whoever they want. They don't even need a valid reason for it. But but honestly, I think it's a bit I don't think it's good to ban people for insulting other people unless they are, making death threats or, something really really bad. Because if you just insult people, like if I call someone an idiot or if I call someone stupid, I mean, it is in you have the right to insult other people, and people have the right to be offended. But I don't think that, like, just because you say stuff like that, that you should be banned from a platform that is about communication and reaching out to people. I don't know. It's just me. Unless you call them something really really bad, or you make a lot of insults targeted towards someone's towards a particular person. I don't know. They banned a really big league, I think, streamer for saying stupid. Oh wow. Oh, wow, I can't play a Smite on stream ever. Like literally, me and my friend. I always play Smite with a friend of mine, and we always call each other like retarded idiots. Like it's our thing. We just call each other that. I mean, as an insult, but like as a joke, obviously. But like all the time, we could never like stream on Twitch playing Smite at all. Oh God. I mean, I don't know. It's I guess like at the end of the day, it's Twitch is a service. It's a platform, but it's also a platform that you don't control. You can be the biggest streamer on Twitch, but you still don't control that platform. You're using someone else's platform, and they reserve the right to ban you if they want to. And I guess a lot of the times people are streaming on their own Twitch channels and they have a lot of liberties, and they don't really realize, or it's not present on their minds that, hey, I'm not using my own platform. This is not my platform. It's just a platform that I was allowed to use by a third party. Um, and I think that sometimes people don't really uh, have that present in their minds. But I also don't think it's okay to ban people just because of stuff like that. But it's their decision, right? I can sit here and say it's not okay all I want, but at the end of the day, they're the ones with the power, right? Although I will say, from a business standpoint, um, I don't know if it's very smart to do that, because if you look at it this way, so I've watched a lot of like clips of Twitch on YouTube and stuff. A lot of the views, like from streamers that are not necessarily very famous, um, every controversial content, everything that is a bit, outside of the normal, day to day stuff, it generates a lot of views, and it obviously also generates a lot of money, not only for Twitch but for the streamers themselves as well. I am not entirely sure if outright making people afraid of getting a bit out of the comfort zone, fearing for their channel being banned. I don't know if that might kill a little bit of the income that they might receive, and a little bit of the income of Twitch as well. I'm not sure, but yeah. Anyway, just to get a little bit on topic again, we did basically finish what we wanted to do for today, because today what I wanted to do was simply fixing the mistake of, well, not really a mistake, but the oversight of last stream, that we didn't have this while true, so the script was just closing. So of course this thread was closing as well. so it couldn't be connected to. But now we fixed that. We also made this threaded. So because everything is threaded now, we can have 3, 10, 500 different clients trying to connect to us, and we can handle all of that at the same time. And our splash screen works. And our verification also works, except there's one thing that doesn't. Let me uncomment this too. The only thing that is not functional at the moment is this. It is functional for, well, not this, sorry. Now I switched locations, I have to switch the comment. This. Because right now the check is equal to true, but we need to perform the actual check at this particular point. And we don't perform the actual check. This is the only thing that is left. As soon as we perform the actual check and we, the only thing we have to do is maybe make a function for the check, assign check to it, and the whole program is functional. The whole ransomware is functional already. And I guess, of course, also generating valid Bitcoin addresses. BRB. Okie dokie. In any case, we don't have a lot of viewers, but if there is anyone with a question, I am opening to answering them now, either on topic or off topic, since this is basically the end of today's stream. Tomorrow, what we're going to be doing is we're going to look at exactly how to generate new Bitcoin wallets and how to monitor for them. And then our ransomware will finally be complete in terms of its functionality. And later on, we're going to improve its code by learning object-oriented programming, making this super neat and more stable, and all of. Oh, also about, I guess I can try about the virus total results, about being fully undetectable. It's not completely fully undetectable now, but it will be. So let's define a system. I'm building a little build script. I'll explain this in a minute, I guess. So let's do a setup. I kind of forget what is in here, honestly. I know that there's a Py2exe in here where it's a dictionary. Is it a dictionary or is it a list? I kind of forget what goes in here. You know what? Let me check that real quick. It should be on my Malkit thing. Where would it be? Oh, it's not on server. Build. Oh yeah, so it's options. Okay, you know what? I'm just gonna copy this because it's just easier to. Oh, and there we go. Bundle files. We don't need this. We don't need this. We don't need this. At Windows, yes. Script equal target. This will be name. And here we can have echo. Okay, so what we're doing here, oops. Oh, yeah. Right, this would be it, I believe. Yeah. What we're doing here is we're simply converting it using a different program other than PyInstaller. We're using PZ37, which is a program that I based on Py2exe and modified. and it should be completely undetectable if we do it like this. So what we got to do, the only thing we have to do, let's import, I guess, and now all we have to do is convert our client.py, which I guess will be here because I'm going to put this on the build. There you go. Then we're going to do move from dist client.exe into client.exe, and then I'm going to delete the whole directory. So rm tree for deleting directories that are non-empty. So I'm going to delete dist, and that's it. And this should work. Oh, we have to install this first. So to install this, it's really easy. All you gotta do. Yeah, it's called PXE37 because when I made this, it was for Python 3.7. I haven't actually updated this for above 3.7. So let's just make another environment with Python 3.7.0. And you can also just download Python 3.7.0 and do this there, or make a virtual environment, or use Miniconda like I'm doing. Activate ransom. Was this it? Yeah. Now do a pip install PXE37, and it should install. Great. Now we're going to do a Python. No, we're going to go and build. Projects, ransomware, build. We're going to delete everything in here. Great. Let's delete the PyCache too, even though, you know, let's delete our actually our test can stay longer. So in our build, we're going to actually copy this over. So build.py is going to be moved into here, and now I just have to execute it. Oh, also we included icons. So to explain a bit, oh hey Wolf, how are you doing? To explain the options here. So this is standard py2exe options, except you append PXE37 instead of py2exe here. We're appending this to simulate that we typed py2exe something. And the idea, so we have bundle files, so it will bundle everything together into one file, which is what we want. Then we can optimize. Zip file equals none. It's just the standard object to not generate a zip file. And then Windows, this could be console if you wanted it to be a console application, but because we don't want it to be a console application, we have GUI there. We want it to be Windows. We don't need any terminals opening. Script is just to define the file that will be converted, in this case file name, so client.py, with the / because it's going to be in the directory below. And icon resources, and you can look this up in py2exe documentation, is just the way to specify icons. And I'm specifying it from the folder called icons, icon.ico. So / because it's not on this folder, it's one directory below. So let's create this, icons. Now I guess we can just go for icons, free icon. Are these actually free? Or is this like one of those? I'm just going to go with this one, I guess. And I'm going to go with here. I guess I'll just use like this one or something. Let's go for icon and downloading, I guess. Which is good for a random icon. I don't really mind. And going into darker books, fundamentals, projects, ransomware, icon. And I'm going to call it icon.ico because that's what I called it here. Okay, so now let's go to build and see if this works. So let's go into build and see if that works. Something went wrong in here. Invalid command. Oh, Oh, do we change this too? I don't remember if that's what we did. We did, yeah. We changed that too, of course. Okay, yeah. I don't remember how I modified it myself. And that's built really easy, really fast. And in the build, there is there's only the build and the client.exe already with this icon. So if we execute our server, let's execute the server. Oops, let's execute the server. Oh, come on. Let's execute the server. Open up the client. Oh, there's a problem. What was the problem? Oh, we have to include modules. Oops. Because it's not included by default. But I believe so. From modules import crypto splash. I believe this might get picked up automatically. So I'm sorry. Let's try this again. So you know what? I'm also going to import OS here, so that before we convert, if os.path that exists client.exe, we're just going to remove client.exe. Okay, let's build it again. So let's go into build and build it. Oh, right, because modules is not there, I guess. Okay, that makes sense. So yeah, okay, that makes sense. Oops, that's not what I wanted to do. Oh, because I don't have, okay, this is actually a huge pain to do. So what I'm gonna do instead is, oops, is I'm gonna drag our build right here, and our build will have current, yes, and we're gonna move it to build. Remove this. Okay, this should be way better actually right now. And we can also do a from modules import crypto and splash. I think this will be picked up in here. No. Oh. Try this out now. Permission denied. Oh, because it's still open. My bad. So, and we have to check if, I'll rechat for a second. Oh, good afternoon. How are you doing, Elementor? Let me also build. There you go. Remove. Well, okay. Let's try this again. It's running it. Easy. There we go. So hopefully it has built it in here. And we have our client already. Now let's run our server and see if this client works. So build. Client is here. It didn't work for some reason. Wait. Can't find modules.splash. Okay. So it seems like I have myself. Oh no, wait. Let me delete the log here. Delete this. Try again, delete the log. So here to generate a new log. So tkinter doesn't happen. Okay, that's great. I have to update my own module. Good to know. Okay. So this doesn't actually include this in there yet, does it now? But Splash includes it. Okay. Forget I said that, by the way. That PXE37 was ready to be used. Apparently it's not. I have to update it. Some stuff is not correctly working. I made it specifically for Malkit project, which I'm not maintaining anymore, but I should. I will get back on that after the courses. And it worked there, but it apparently doesn't work here because there are some module import errors. I still have to fix those, and I will. But for now, let's just stick with PyInstaller, I guess. And with PyInstaller, we only get 2 detections. It's not the worst thing in the world. These 2 detections are basically nothing. But I'm still going to fix the PXE37 so we can actually use it. In any case, this was basically all I wanted to show you today. Thank you so much for coming by. And just as a quick recap for what we did, we solved the problem with our server, which of course was that the program was just closing, so we didn't have this while true. We made everything threaded, so now multiple clients can connect at the same time and receive different Bitcoin addresses and encrypt everything. And yeah, we fixed our splash as well so that it keeps querying until it has been paid. And that's it. That's basically what we did. I missed a bit, but I'll check the video after. Oh, thanks. We did a little bit, but not too much. Actually, we just expanded a bit on what we did yesterday. And basically, the entire ransomware is very close to being finished. The only thing left to finish the full functionality of the ransomware is this: to change this check equals true to checking the payment, and then our full functionality will be done. Oh, and of course we have to create a Bitcoin wallet. That's all we got to do, and this is what we're going to be doing in the next stream. So I'm sorry that you basically arrived when I was finishing, but I hope you enjoyed the video afterwards. And if there are any questions on or off topic, I'm ready to answer them. Stream will stop in, I guess, around 5 minutes. So yeah, now it's just question time. Also, I just remembered what I did for my Pixie 37. I think I did have some import problems before, and essentially what I did to be a bit lazy and not have to solve them, I created modules on PyPy and just imported them here and then the conversion worked perfectly. So I might do that, but I want to fix this. Oh, important thing to remember. If you check PyInstaller, the reason I get 2 detections, you might get more. The reason I get 2 detections is because I just compiled out the bootloader, which you should do, by the way. All you have to do is just clone this project and go into bootloader. Yeah, go into bootloader and execute WAF. Just go Python or just execute. I think this is all you gotta do, and then it will generate bootloaders, and then you do a pip install of the thing after you generated the bootloader. I can do it with you if you want. So let me show you this. This is a new virtual environment. I don't have PyInstaller yet, so let's install PyInstaller. Oops. Oh. Go. Building dependencies, whatnot. Let's delete this. Not working anyway. It's going to install. So this is not actually building it already. This is what you would normally do. It's what I told you to do in the beginning. And I'm going to show you that this leads to more virus detections, or it should. Let's do a PyInstaller for our client.py. Let's do an fw. This works well. There we go. It's done. And now if we go into VirusTotal and we choose the file, we're going to build ransomware distribution client.exe. Is this it? I feel like this is not it. this it? It is it. Yes, it is it. This should have more detections now. There you go. We can see some extra detections that we're not. There we go. So you can see a lot of detections already. There we go. See, so we have a lot of detections on this one. So this is not something you want to do. You don't want to use PyInstaller as is. The reason we get a lot of detections is because a lot of people are using PyInstaller to, of course, convert their Python malware into executables. And so instead of trying to detect through behavior analysis and further heuristics, they just detect the signature of the bootloaders being used by PyInstaller, which can, of course, lead to false positives when you build actual non-malware in Python and want to convert that into an executable. So 18 engines. So the only thing you need to do after you clone this, so now I'm going to uninstall it. PyInstaller. I'm just uninstalling it altogether. Going up to their GitHub, copying this, git clone, cloning this into this directory or whatever. If it takes, it works. Now, I believe you might you should. I think you requires. There are some requirements for this. It should be somewhere in the doc. So here. It doesn't list it here. I don't know if there are any Oh, no. Maybe there aren't any requirements except for some plus plus. I'm not sure. There should be like a documentation of this. I feel like if you like if there's a manual, I feel like in the manual it should be there. Oh, building the bootloader. Oh, so you have building for Linux, you have building for Mac, you have building for Windows. Oh, there we go. So you need either the Visual Studio C++ compiler or the MinGGW suite. Or I guess you can also, yeah, you can also use this. So I'm guessing the easiest one would just to use the Visual Studio compiler. Just download Visual Studio. So after cloning this, you go into PyInstaller, you go into Bootloader, and all you have to do is exactly what they say here. You just execute WAF wherever they say this. Where do they say this? Yeah, here. So Python WAF all. So you just do Python WAF all, and then this should start building the bootloader. So it's checking for the compilers, and I do have it because I have Visual Studio 2017 installed. And then it's doing it's building the bootloaders, and when it's done, oh, and it's done now. So now all you do is pip install -e dot, oops, you have to go into the main directory, and you install this version with the correct bootloaders. And after you do this, let's now delete. So we have our build, delete this. We have our dist, delete this too. So now we can do the same thing we did before with the PyInstaller, with the client.py. Oops. There we go. And let's wait for this to finish. And now if you go into virus total, so remember 18, now you choose the client again. This time it's the client that was built using PyInstaller with our own built bootloaders. It should have about 2 detections, and that's it. And these 2 detections don't really matter. These are things that no one uses, and I guess it will bypass most things anyway. But I still want to make the the PXZ37 working so it can be fully undetected. But come on. Now, that anymore. So cute. Oh, wow, so many windows open anyway. Well, this is the last thing I'm going to show you, I guess. So a bunch of stuff that was detected before we see is not being detected. And this still works, by the way. You can never have too many windows open. That is true. So yeah, Sinet, and there's one more that always detects this as well. There we go. And Secure Age Apex. Those are the two detections you're gonna get. And it does work. So if I show you working it, if I show it working, I mean, I showed it working before, so we know that it works, but just because, see, oh, you won't be able to see this because it's going to spawn on my other monitor, I believe. Yeah, it spawned on my other monitor. You can't see this. My bad. But yeah, on my, actually, you can see this if I, oh, oh. Well, um, let's wait a bit. I'll find a way to you see that, make you see it. So in here, on display capture, I'm going to change this to display number 1, which is this one. So when I click on the client, so let's put it here, I click on the client. There we go. I'm hoping you can see this, because I can't see anything that's happening because, you know, I try to close it, it won't let me close it. I hope you're seeing this. And it's gonna wait for a couple seconds until our fake payment gate says, "Oh yeah, it's paid. Now files are being recovered." And it's gonna be around 5 seconds. There we go. So hopefully you did see that. Let's switch this back to display number 2. Yeah, that works. Awesome. So yeah, you can see the executable actually works. So it's not because a lot of the times because you always got to test it, because maybe your obfuscation or your evasion techniques made the file not work at all, so it's not detected because it's not a malware. It doesn't work. So I just wanted to show you that it does work. But yeah, and that's all there is to it. Anyway, thank you so much for coming by, and yeah, I will have to be going now. But I hope you appreciated this lesson. I hope it was instructive, as always. And happy hacking, guys. Thanks, Lament. You're welcome.